Good afternoon or good morning, depending on which side of the continent you're on here. I am Tim Smith, the Solutions Architect here at Veeam, and today we're going to cover Veeam Backup and Replication Sizing Best Practices. A little bit of housekeeping about the webinar. Everyone is automatically muted upon entry. If you do have any questions, feel free to use the questions section in GoToWebinar. I'll try to get to those if I can throughout the presentation, or at the end, or at the very end, at least be able to answer those via text as well. And then, of course, we're going to post this recording after the fact along with the slide deck. So be sure to check your email for those if you happen to miss something throughout the webinar. So for our agenda, we're going to look at the components, the main components of Veeam Backup and Replication, and then we're going to size those major components, right? The backup server, proxies, repositories, combining proxy and repository to have a combo server. And then we're going to talk a little bit about the laws of physics and finish up with our takeaways. So just a brief overview. This is a really simple diagram, right, of Veeam Backup and Replication. You can see number one there, we've got our Veeam Backup server. That's the main UI of the product. This is where we're creating our jobs, doing restores. It's backed by a SQL database. Number two, that can be SQL Express if you happen to just do a next install, or you can also choose to deploy to a SQL standard server, either on the VBR box itself or a separate machine. Three, we have our proxy servers. The proxy servers are responsible for grabbing that source data, let's say from your vSphere environment, reading that data and getting that compressed, sending it off to your repository server, which is number four, right? The repository server, maybe it's a Windows or a Linux server. This is where your backups are going to land to disk. Maybe your repository, though, is a deduplication device, so you might have a gateway server in front of that. Number five is the Veeam Backup Enterprise Manager. This is going to be a web UI for if you need to manage multiple VBR servers, multiple backup and replication servers. Maybe have a self-service restore portal there as well. And then last is that combo server, which I talked about, is that combination of the proxy and the repository, typically found on physical servers, right, where you have this one or group of servers handling both that data source retrieval role, that proxy role, and landing it onto disk, that repository role. So let's get into what do we need when we're going to look at an environment to start sizing it. Well, obviously, we're going to need to know how much source data is in that environment, typically in terabytes. How many virtual machines or servers need to be protected. If it's a virtual environment, additional points if you happen to have the number of virtual disks handy. And that's just because when we're sizing proxies, a proxy task is based on a disk that it's processing at one time, how many disks at one time. What is the backup window? Do you have a backup window? Backup windows seem to be going away more and more. Right, a lot of virtual machines can handle getting a snapshot being taken of them. VMFS has changed over the years, so snapshot committals result in much less stun. So maybe you don't even have a backup window, but if you do, what is it? Because we need to make sure we can process that amount of data in that amount of time. What about your change rate? Do you happen to know your change rate? Maybe you installed Veeam 1 in your environment and you already have reports that show your change rate. If you don't, we've got some fairly good estimates here. 5% is kind of an optimistic estimate for change rate. 10% is a more conservative estimate for change rate. And then last, what is your required retention scheme? How many days do you need on site? How many days do you need off site? We're going to be doing a forever forward incremental, reverse incremental, synthetic, active fulls in there. And additional bonus points, right? If you know your RPO, RTOs, your recover point objective, your recovery time objective, because those are going to tell us how often we need to schedule your backup jobs and also help you make decisions on what type of storage you want your backups to go to so you can meet your RTO and have performant restores from that storage. So as we're figuring out the sizing of all of these components, we're going to be walking through a customer example throughout this. So we'll learn about how to size a particular component, then we'll walk through how this was sized with our customer example. So For our customer example, we had a customer that had 260 terabytes of data in approximately 2,000 virtual machines. They did have a backup window of 8 hours, and we went with a conservative change rate estimate of 10% for them. And then they needed 14 days of on-site retention, as well as those same 14 days off-site with some GFS, 4 weeklies, 6 monthlies. So we're going to start with our backup server. And in a real world sizing environment, you're probably actually going to be doing your backup server last because we are going to want to know how many jobs we're going to have, which is determined by how many virtual machines you have, things like that. So in a real world environment, you're going to be doing the backup server last. However, this has already been sized, and it's best to present it this way so we can walk through the components as we go. But for sizing the VBR server, the backup and replication server, we're going to say 1 core for every 10 actively running jobs. And again, that's for an actively running or concurrently running jobs. So if you have 50 jobs on your Veeam Backup and Replication server, but only 10 run at a time, then we're going to size it based on those 10. So they would need 1 core, for instance. And the same for RAM, right? 512 meg for every actively running job at its busiest time. So that's pretty straightforward. Space is going to be a little bit different for the VBR server. We're going to need logs, right, for every job that we have running. And we're going to say 3 gigabytes of disk space for every 100 virtual machines that back up once per day. So if you back up 200 virtual machines, that would be 6 gigabytes. Or if you back up 100 virtual machines 2 times a day, that would also be approximately 6 gigabytes of disk space needed. Now, we'll also need disk space if you're using guest file indexing. So that's going to be 100 meg for every 1 million files on Windows machines. And if you're indexing Linux machines, it's going to be 50 meg for every 1 million files. Now, we're going to do a little bit of post-processing on those and get those down to about 2 meg for every 1 million files compressed when we send it off then to Enterprise Manager. Now, like I said, typically you're going to be sizing your backup server last because you're going to want to know how many jobs you have, and that's going to be based off of your virtual machines. And then don't forget as well, the number of jobs is not equal to the number of concurrent jobs when we're looking at sizing. We want to know sizing based off of how many jobs will be running at one time. If you do happen to have a lot of jobs, staggering the start and times of those jobs can also reduce load on your backup server. If you happen to have an environment where you have to keep your CPU usage down, maybe we'll want to stagger those backup times so not as many run at one time. Otherwise, we'll want to make sure we definitely size for the ones that will be running. And please don't use your backup server for other tasks, other software installed on there, other than SQL, of course, right? SQL Express comes with it. You can install SQL Standard on the VBR server as well. But the recommended defaults are going to be 4 CPU and 8 gig of RAM and 60 gigabytes of disk space. So let's look at our customer example calculation. We have 2,000 virtual machines. We're going to be doing per VM backups on our repository. And we've got 14 days of on-site retention and then off-site retention 14 days with that GFS 4 weeklies, 6 monthlies. And now you'll notice here I have backup job and backup copy job. This has actually been changed, and we're no longer going to use a backup copy job thanks to V10 features. But we will still show an example here with backup copy job sizing with GFS. And then in our customer example, we'll actually show how that's going to be different. But for our customers, 2,000 virtual machines, because we're going to repositories based on per VM, the best practices would say 250 virtual machines per job. So we'll go ahead and take our 2,000 VMs, divide that by 250, tells us that we're going to need 8 jobs. So those 8 jobs times 512 meg tells us we'll need 4 gig of RAM. Likewise, 8 is less than that 10 concurrently running jobs that we talked about, right? 1 core for every 10 concurrent jobs. So the 1 core is fine. which means here we can stick with our recommended defaults of 4 CPU and 8 gig of RAM. So we'll go on to our database server now. So just like the backup server, we're going to be looking at the number of concurrent jobs. For our database server, we're going to say 2 CPU or 2 cores for every 25 concurrent jobs. Now, this is going to be, if you put this on your VBR server, let's say you install SQL Standard on your VBR server, right? These will be in addition to the requirements that we just went through. So for RAM as well, 4 gigabytes for every 25 concurrently running jobs. Now, disk space typically is going to be in the single digits of gigabytes. It can be much higher, and that's going to depend about what types of jobs we're running, how frequently they run. So when we're looking at some tips here about that, right? In the database is mostly going to be transaction history, right? Job runs, performance, information, things like that about each one of those job runs. So the more small jobs, if we have a lot of jobs that are small and run frequently, they're going to consume more disk space in that database than if we have less jobs that run less frequently. Now, SQL Express would be installed if you just do a next install of VBR, right? But there are some limitations to SQL Express. The first would be that the database cannot go greater than 10 gigabytes. Also, you're limited to you're limited to 1 gigabyte of RAM usage. And then also you're limited to using the first 4 cores of the first socket. So even if you have a machine with 4 sockets with 20 cores each, SQL Express will only use the first 4 cores of that first socket. So again, you're going to see some limitations there if you do stick with SQL Express. However, that being said, when do we need to go to SQL Standard? Well, if you're protecting more than 500 virtual machines, we're going to recommend that you go ahead and go with SQL Standard. If you're going to be using files to tape jobs, especially a lot, we're going to recommend SQL Standard as well because your database size is going to grow. If you have needs for an external staging server, or I should say if you don't have an existing SQL server that you can use for a staging server, you'll probably want to install SQL Standard so you can use that for your staging environment as well. Recommended defaults here, whether that's going to be your existing SQL server, a physical server, virtual machine, your Veeam Backup and Replication server, doesn't make a difference. However, we will say the recommended defaults are those 2 CPU, 4 gig of RAM, and approximately 2 to 10 gigabytes of disk space, obviously depending on what types of jobs we're running. So for our customer example, we had 2,000 virtual machines. We were doing the per VM backups. We figured out we had 8 backup jobs, right? Originally 8 backup copy jobs. We've since redesigned that. But the 2,000 virtual machines is already greater than 500 virtual machines, which was that point where we recommended going ahead and going to SQL Standard. Likewise, the 8 jobs, though, is less than 25 concurrent jobs. So here we can just say 2 CPU, 4 gig of RAM, keeping those recommended defaults. However, we are going to be deploying this on an existing SQL server that we had. So they let their infrastructure and database team know that the SQL server would be getting an additional load of that approximately 2 core usage and 4 gigabytes of RAM. I will address one question here that came up. Does CPU recommendation consider CPU hyper-threading? So when we're talking about CPUs, it's going to be, we're looking at the core. So if this is installed in a virtual machine, the virtual machine may be using a hyper-threading depending on how your hypervisor is set up. But we're actually going to be looking at either the physical core or the virtual core that has been given to the virtual machines. All right, so let's go ahead and talk about our proxy servers. So version 10, of course, added a Linux proxy. So now we can do use Linux proxies in our vSphere environment to handle backups via hot add. Right, this is going to be hot add only. We're not going to be doing direct storage mode here, where you can't do network mode here. But this is fine because hot add mode is a very performant backup method. So our Linux appliances will get that virtual disk added to it, right? Do the backup, detach that virtual disk, and continue on now. We'll talk about the recommended defaults here, but for virtual machines, the recommended defaults are 4 CPU and 8 gig of RAM. But there was also another new proxy type that got added in recently as well, and that was the proxy for Nutanix AHV. So not only do we have now Windows proxies, Linux proxies, we also have a proxy that will run inside of the AHV hypervisor. This is going to be backing up virtual machines that exist in that AHV cluster only. This proxy is also going to be the web UI front end of where the AHV backup jobs are defined. So you could do a full virtual machine restore as well in that console, or you can do restores through the backup and replication server as well. The difference here would be when we're talking about sizing is going to be in the RAM usage. So for proxy servers, we'll say 1 CPU for every task, and a task is going to be a virtual disk. So if a virtual machine has 5 VMDKs or 5 virtual disks, that's going to be 5 tasks to back up the machine. Likewise, we're going to say 2 gigabytes of RAM for every task. The difference there is for Nutanix, that proxy is only going to require 1 gigabyte of RAM per task. So here we have it top to your average processing speeds. And this seems to be about the same no matter the processors. It can vary up and down depending on frequencies, right? But on average, you're going to get about 100 megabytes per second throughput on a full backup. And you're going to see about 25 megabytes per second throughput on incrementals. And obviously, the full is going to see a greater throughput, right? Because it's more of a serial read, right? We're doing a sequential read, of that data, or a sequential write, basically down to disk. Whereas an incremental process, right, we're going to be looking for blocks here and there, so that rate is going to be a little bit lower there. So to determine how many cores and how much RAM we need, we're going to take that source amount of data that we're going to be backing up, dividing that by our backup window in seconds. And that's going to tell us how many megabytes per second throughput we need to process this data. We can then take that throughput and divide it by that average process speed. Let's say 100 megabytes for a full backup, and that's going to tell us the number of cores that we need. And then we can take the number of cores, multiply that times the gig per task, let's say 2 gig, because we're going to do Windows proxies here in a vSphere environment, and that will tell us how many gigabytes of RAM we're going to need. So again, per task is per VMDK. It's not per job when we're talking about proxy servers. And just a couple other questions here. Proxy servers do not require additional licensing. So Veeam licensing is going to be per socket, or it's going to be per VM, depending on which licensing model you have purchased. And is there an advantage to using Linux versus Windows proxies? So Linux proxies are going to be hot add only. If you're a heavy Linux shop, or you have specific licensing recommendations or limitations, then Linux proxies might be the way to go. If you need to do direct storage access, or if you already have Windows licensing in place and it doesn't matter, or you need to do network mode, then Windows proxies would be just as fine. Performance-wise, though, with hot add, you're going to see the same performance between Windows and Linux. So for our customer example, here, some tips for sizing. Compression rate, right? So by default, we're going to say optimal compression. And we have a couple other options that you can do in there. You can bump that up one to high compression, or extreme compression past that. But if you go from optimal compression to high compression, you'll see about a 10% gain, or I should say a 10% additional reduction in your data. But that's going to be at the cost of 10 times the processing usage. So that may not be worth it in your environment to gain just an additional 10%. If you have really constrained disk space, but plenty of CPU to consume, maybe you're going to want to bump that up then, and you'll go ahead and take that processing hit for that additional space savings. Don't forget though, if the underlying infrastructure cannot support high throughput, then throwing more processors at your proxy servers isn't going to help. If you can only write to 2 SATA disks over a 1 gig link in some NAS, but you have 50 proxies with 8 CPUs each, well, they're going to be sitting there doing nothing because the bottleneck is going to be over on the storage side. And that's a pretty extreme example, but just remember the underlying infrastructure, right? You're going from that source across the proxy, maybe over the network to your repository if they're different machines, and then down to disk. So it might be worthwhile to make sure that you can write that data as fast as it can be read from those proxies. Also, don't forget that large VMDKs cannot be processed by multiple proxies. Again, each task is per VMDK. So if you do have a large VMDK, that may take a little bit as that proxy is going to be processing that. So recommended defaults, if you're going to be running virtual proxies, recommended defaults just going to be 4 CPU, 8 gig of RAM, right? It was 1 CPU for every 2 gig. If you're going to go with physical proxies, we're going to bump up the recommendations to 20 CPU and 128 gig of RAM. Reasons for that being is if you're already buying physical servers, you're probably not going to buy a single socket 4-core processor with 4 gigabytes of RAM. You're going to typically find that bumping up that processor to a higher core count or adding another 64 gigabytes of RAM is not going to be that much more expensive to what you're already paying for the server. And typically we're going to be using this proxy to handle a heavier workload or even as a combo server because it has disk in it that we're going to be consuming for repositories. So for our customer example, we had that 260 terabytes of source data, right? We're going to be doing those per VM backups. We had a backup window of 8 hours, and we were estimating that 10% daily change rate. So when we're trying to find out how many cores and how much RAM we're need for our proxies for a full backup, we're going to take that 260 terabytes, multiply that down to megabytes, take our 8-hour backup window and multiply that down to seconds to get 9,467 megabytes per second throughput needed. We're then going to take that throughput needed, divide it by our average full backup speed of 100 megabytes per second. And that's going to tell us then that we need approximately 95 cores to process this amount of data in that amount of time. We'll multiply that by 2 gigabytes per RAM, right? Because it was 1 CPU, 2 gig of RAM per task. That's going to give us 190 gigabytes of RAM. So if we wanted to size for a full backup environment here and we were doing physical servers using the recommended 20 cores for physical servers, 95 divided by 20 would give us 5 physical proxies with 20 cores and 40 gigabytes of RAM needed for sure. If we wanted to go virtual and stick with just the 4 cores per virtual machine, that would give us 24 virtual machines with 4 cores and 8 gigabytes of RAM each. Now, obviously, you can adjust those numbers up. We can go to 6 cores if we needed to, or your physical servers if you want to go up to 40 cores and 80 gig of RAM to reduce the number of physical servers you might have. But that's our full backup size. What do we need though when we're doing an incremental? Well, when we're looking at incrementals, we're essentially going to be taking our change rate, or 10% was what we estimated was our daily change rate. So 10% of our full backup size, our data source data, multiplied down to megabytes with our backup window as well, 947 megabytes. Or we could have just taken 10% of that 9,470 megabytes we had for our full. But we'll divide this down by the average processing rate of an incremental, and that will tell us we'll need about 38 cores. Multiply that by 2 gig of RAM, 76 gig of RAM needed. So you can see here we're already saying that for incrementals, if we did the 20 cores in a physical machine, we'll only need 2 physical proxies instead of 5. And if we're going to do virtual machines, sticking with 4 cores each, we'll need 10 instead of 24. So then the question comes in, well, do I size towards full backups or do I size towards incremental backups? Well, if you're going to do an active full backup every single night, then definitely going to need to size for the full backups. However, most people are going to be doing weekly full backups. And then even at that, they're probably going to be doing a synthetic full backup and not an active full backup. Remember, an active full backup's reading that source data from, let's say, vSphere, whereas a synthetic full is going to do an incremental backup and then synthetically create that full backup on the repository. So a lot of times we're going to end up sizing more towards our incremental numbers. So if you are, let's say, installing Veeam for the first time in your environment, and you did have this 260 terabytes, you might end up creating a couple jobs to start with, and then adding more virtual machines in later in the week. And instead of doing one big job or running all your jobs at the same time. Otherwise, if you're doing active full backups weekly as well, you might want to say that job A is doing its active full on Saturday. Maybe job B is going to do its active full on Sunday. Job C maybe on Monday, things like that. So you can stagger them around if you needed to have that lower consumption of resources on your proxies. All right, so we had a question. Is there an Excel calculator spreadsheet for this? So you can contact your Veeam SE and they can work through a sizing operation with you. We also have, you can see that there's a community supported restore point simulator, rps.dewin.me. It's a great calculator that will help you find out especially how much disk space you're going to need in your repositories as well. Does CPU core speed matter so much in the sizing? Well, not so much. There are small differences with faster CPUs and slower CPUs, but on average, you're going to see that 100 megabytes per second and 25 megabytes per second. The higher frequency CPUs, you'll probably see a little bit less of a performance decrease, switching up to like extreme compression, since they'll be able to handle that a little bit better than some of our lower clock counts. But typically as time has progressed, right, the clock speeds have maybe not gone up as much, but the actual architecture of the CPUs has changed over time, that it's kind of all balanced out. All right, so let's go ahead and take a look at our repository servers. Repository server sizing is again going to be per task, but this task is not going to be based off of virtual disks. The per task is going to be based off of a particular backup chain. So if we have a regular backup repository set up, right, where all of our virtual machines maybe go to one backup chain, VBK and VIB files, that's going to be one task. If our repository is set up to do per Veeam backup files, then each virtual machine that comes in to be written down to disk will be its own chain, because we're doing per virtual machine chains. And that will be its own task. So when we talk about tasks on repository servers, we're looking at the actual VBK VIB backup chain that will be written to disk, each one of those chains being a task. And that's going to be one CPU or one core for every task. Likewise, when we're looking at RAM, it's going to be 4 gigabytes of RAM for every task. Now, the space that we need is going to be based off of our retention method and how many restore points we're going to have. You can see here we have forever forward incremental. In the middle, we have forward incremental with a synthetic backup. Maybe that's an active full backup, or reverse incremental on the right. That one in the middle there is potentially going to consume more space than the ones on the left and the right, just because we have that additional full backup or that VBK file. So a synthetic full is going to consume the same as an active full. However, we do have some technology that will help us have a synthetic full take up just the same amount of space as an incremental. And we'll talk about that in a little bit when we talk about REFS and XFS. So how to size our space usage for our repository. Like I said, it's going to be based off the retention points and what backup method we use. But first, we're going to start with our source amount of data, and we're going to go ahead and say on an average 50% data reduction. And that's going to give us our full backup size. And then for our incremental backup size, we're going to take that source data times our change rate. So we're going to take 10% of our source data, and we're going to also apply that 50% data reduction to it. And that's going to be our incremental size approximately. So what does that mean here? Well, when we're trying to figure out the total amount of space, we'll take our full backup size, because that's going to be our first backup, right? Has to be a full. And then we're going to look at our incremental size times the number of restore points we said we want minus 1. And we say restore points minus 1 because if you have 14 restore points, well, your first restore point is actually your full here. And then you'll have 13 incrementals. So 14 minus 1 is 13. So our full plus our incrementals plus any workspace is going to be the total amount of capacity that we need in our repository. Now, when we're looking at a backup job with GFS, right, version 10 added the ability to put grandfather, father, son backups in your primary backup job, no longer just in backup copy jobs. So if we're looking at GFS, whether it's a backup job or a backup copy job, sizing is going to be a little bit different. The beginning is the same, right? All of our capacity days, which would be our normal restore points, full plus those incrementals. However, we now need to add in our GFS, our weeklies, monthlies, and yearlies. So when we're writing to, let's say, a NAS or an SMB share, what we're going to do then is take the capacity days, this first calculation, plus our full backup for every weekly that we have and every monthly that we have and every yearly that we have. So each GFS point is going to be a VBK, so it can be a self-contained restore point. And then we're going to add in that workspace for our total capacity. Now, where this is going to change, this calculation here, we'll see it in the customer example. This is going to be different because of the way that REFS or XFS or even object storage works. We're not going to be using our full size here for each one of our GFS restore points. Quick questions. PowerPoint recordings will be available. PowerPoint and the recordings will be available after the fact. You'll get an email with those as well after the webinar. So workspace. What is the workspace needed for? We had that in our equation just a little bit ago when we were doing the repository size. Workspace is required, right? Maybe we're going to manually run a full occasionally. We need workspace, right? Because we don't want to fill our backup repository. Just like nobody wants to fill their vSphere data stores because all the virtual machines stop. We don't want to do that for our repository either, right? You fill any file system up and you're no longer able to write to it. Backup processes need housekeeping space. Let's say we're going to do a forever forward incremental. That way we take our first full backup of VBK, everything after that is an incremental, but you tell it you want 14 restore points. Well, now on day 15, we write our new incremental down, and that's technically 16 restore points, or I'm sorry, 15 restore points, but we said we want 14. So now we need to start the merge process. We're going to need some disk space too to do those writes and reads to get that oldest incremental injected into that full backup file to synthetically move that full backup up one day. So that's just one example how, backup processes, synthetic fulls, merges, things like that can take up some temporary space on your repositories while it's getting that synthetic operation done. Somebody asked earlier about a link to the calculator I used. It's right here on the screen, rps.dewin.me. And you'll also see workspace is available to be calculated when you're doing backup sizes there. And this is kind of an explanation of how that workspace can kind of be calculated. And it's going to be this bucket system, which we will kind of fill and spill. But you're going to take the source amount of data that you have and multiply it by your data reduction, which 50% is what we talked about, and then multiply it by this bucket multiplier. And then we'll go to the next bucket and so on until we've used all of our source data. And this will make a lot more sense in our customer example as well on how we estimate the amount of workspace that's needed. But again, don't forget tips for sizing your repository. That workspace is crucial. We don't want to fill up your backup repository. Don't forget that your backup repositories are going to be receiving multiple incoming streams. They're going to do that dedupe then and compression and then write it down to a single file. So if you don't have per VM backup enabled on your repository, maybe it's a traditional backup repository, right? But you have 5 different proxies that are reading from, let's say you have a small number, 25 virtual machines that you're backing up at one time. And those 5 proxies are processing those virtual machines. So what's going to happen is each one of those proxies is sending that data over to the repository server. The repository server then is going to be deduping that data and writing it down then to a single file. So what's being written to disk is going to be less than what's being sent over the network from your proxies to your repository server. And then last, when you're sizing your repositories, don't forget that a lot of times the underlying storage is actually going to be the bottleneck. Right? Keep in mind the RAID type that you're using, maybe RAID 10, maybe you're going to do RAID 60, RAID 6, RAID 5. It all depends. A 4-disk RAID 10 might be slower than a 48-disk RAID 60. Right? So it all depends on how many disks you have, how many spindles, and what type of I/O you're going to get, what sort of write penalty you have, as well as then, if you're going to be doing a reverse incremental versus a forever forward incremental, that will also depend on how many reads and writes are being done to the repository at one time. And then connection to your backup repository as well. Is it over the SAN? Is it over an NFS connection? Please don't ever route over NFS, but so, keep in mind your underlying storage for sure. And last, for SMB or deduplication repositories, sometimes the mount server can actually become a bottleneck. So when we're doing a backup, right, you've got, let's say, 5 proxies reading that data from your virtual machines. But now we need to do a synthetic full operation. Well, the proxy servers don't do a synthetic full operation. They grab the data from the source. The synthetic operation is data that's already in the repository. So if you're running an SMB-based repository or a deduplication device, then the mount server is going to be responsible for reading that data and doing that synthetic operation. So if you do have a dedupe appliance, one of the best things to do would be utilize, let's say, Catalyst for store once or ddboost for data domain, right, to greatly speed up that synthetic operation as we're talking over their native language now. But if you're just going to SMB or dedupe appliances without that integration, sometimes creating multiple repositories will help because then you can have multiple mount servers, so each one of them can be handling synthetic operations at one time. The recommended defaults for a, let's say, a Windows physical repository is going to be that 20 CPU, 128 gig RAM, 100 gig of disk space for the OS and updates, and then XX terabytes, whatever backup space we just sized for your environment. So I talked about REFS and XFS in there, and we're able to use fast clone to get spaceless fulls on there. And what that means is, right, what we used to do is when we, let's say we're doing a synthetic full on an NTFS partition, what happens is, right, we write that incremental down, then we can go ahead and take that VBK, that full backup that we had, start injecting, copy data bits from that over in with this incremental backup and get them all injected in there to synthetically create a full backup there on disk. But now we're consuming another full backup size there, right? If you had a full backup that was, let's say, 100 gig, that's really tiny, but 100 gig, you're going to have now another 100 gig full backup file. However, when we're doing REFS or XFS and we can utilize the block clone technology, what we can do is write that incremental down and then basically create a VBK file that simply references the other blocks on the VBK that's already there, because we already had that data there on disk. So now both full backups are going to be referencing the same blocks, which means that our synthetic full backup is now the same size as an incremental, giving that spaceless full. So this does a couple things, right? This reduces the disk space because now it's a spaceless full. It's the size of an incremental. It also increases the speed of our synthetic operation. Maybe you had something, a backup job that took an hour to have a synthetic full done because of the reads and writes. That may be done in now a minute and a half, if that even, because of the synthetic operation with fast cloning. And because now we're not doing all those reads and writes and we're just referencing existing blocks, we're also going to be decreasing the load then on that storage device. Now, for those of you who get GhostDev's word of the day from the Veeam forums in your emails, and if you don't, please go subscribe to that. It's wonderful information from him every week. You'll know that SMB repositories are not a favorite because there's some inherent issues with SMB in writing over the network. Now, however, SMB continuously available shares, CA shares, are a different story. We don't have those issues because just the way the technology is. But a little trick here, or a little a side note, is that fast clone is available for SMB 311 with particular flags set. But please only do this if you do have CA shares available. Maybe going over to an existing Windows server. But you can get a fast cloning enabled if you are going to a Windows server with CA shares with REFS set up on there. For XFS, you can see we have a couple requirements. Ubuntu 8.04, the file system needs to be XFS, and you can see the ref link CRC equal to 1 is the formatting down there. The block size is what we're going to need for the XFS formatting. So when you are implementing fast clone, whether on XFS or REFS, make sure that your repositories have enough RAM. And if you're doing REFS, make sure that you're using the latest updates for Windows 2016 or 2019, right? Microsoft's made a lot of updates to REFS over the years, but we're still going to say if you're using REFS, 1 GB of RAM for every terabyte potentially of disk space that you're going to be consuming for your backups, up to about, I think it was 180 some gigabytes of RAM is kind of the cutoff, but make sure you give your machine's RAM because there's going to be a lot of block referencing that's being done. So if you find that you have slow fast clone performance, it's probably going to be because we don't have enough RAM in your repository, or we're using an older update of Windows that doesn't have the latest REFS bits. So for our customer example, they're actually going to be using a scale-out backup repository. Version 10, well, prior to version 10, right, we had the ability to scale out to object storage. Minio is an example here, but let's say Azure Blob, AWS S3, S3 compatible, IBM Cloud, right? But it was only that bottom checkbox, the move backups to object storage as they aged out, which meant that anything older than 14 days would be moved to object storage in this case. Version 10, we added the copy function, which means that as soon as a backup lands to disk, we're also going to copy it to object storage. And if we use both of these, now we don't have the need for a backup copy job anymore because what we're doing, both of these, with GFS enabled in our primary job, means we can get everything we need done in a primary job if needed. I can write my backups to disk. They're immediately copied off to object storage. My grandfather, father, sons will be on local disk once they're older than 14 days, let's say, because my retention was 14 days. Once my grandfather, father, sons are older than 14 days, I'm keeping those around for 4 weeks, 6 months. They'll be moved, they'll exist only in object storage. I won't say they'll be moved because they'll already have been moved because they're copied as soon as they're created. So the copy on premises will be removed, the copy off premises will be retained. So let's look at our customer example here. We had 260 terabytes of source data, and we had 14 days of retention on premises and 14 days of retention off premises, as well as those 4 weeklies and 6 monthlies for our GFS. And we had that 10% daily change rate. So we're going to go ahead and look at our calculations. 260 terabytes with a 50% data reduction tells us that we'll have approximately 130 terabytes for a full backup, and 10% of that will be 13 terabytes for our incrementals. We're going to go ahead and you can see that calculation there. For our total restore points, our full backup, 130 times 1, plus our incrementals, 13 terabytes times 13 restore points, because our first restore point is here, plus our workspace, which we'll get to that example with the buckets on the next slide, tells us we need 343 terabytes. Now, offsite, we're going to need the same thing, right? We need our full, we need our incrementals, but we don't need workspace. Because we're copying the object storage, all the work has already been done on premises, so we don't need that workspace up there in object storage. There's nothing to work with. We're just throwing it up in object storage. So 299 terabytes for the 14 days, or our capacity days, and then our GFS. Right, we're going to have adding in our GFS here to that 299. You can see I'm not using the full backup size here. I'm using 13 terabytes for each one of our weeklies. So 13 times 4 weeklies, 13 times 6 weeklies, plus our 299 terabytes tells us that we need a minimum of 429 terabytes in object storage. And I say minimum here because this incremental might end up being larger. And the reason for that is the farther away from our latest backup that we get, the more data we're going to have changed. So, right, let's say we have that 13 terabytes, that 10% change rate every night. Well, that's probably just going to be the same files every night getting changed, the same databases getting changed, right? But pretty much Windows, you didn't update it last night. So, you know, that 40 gig of Windows is probably the same on each one of your servers. However, 6 months ago, you've probably done, hopefully, some rounds of Windows updates. And this is just an example. So the bits that existed in Windows at the time 6 months ago are going to be a lot more different than last night's backup than compared to the night before, right? So the farther away we get on our GFS, the greater change we'll actually see, and we'll have additional data that needs to be around. So at minimum, it's going to be the incremental size times this. But since I'm going to object storage, let's say I'm going to Azure Blob. Well, they're going to have the disk space there. I just need to know that I'll be consuming it, and I will be able to consume it. So at minimum, I'll need 429 terabytes approximately, or greater 6 months from now. So let's get into that workspace and the buckets with our customer example. And this is how that restore point simulator and how we estimate workspace that's going to be needed. And it will also vary depending on what type of operation is being done, but this is a good rule of thumb. Is we take our data, my 260 terabytes, and I'm going to start putting it in the first bucket. And that first bucket can hold everything between 0 and 10 terabytes. So it's going to hold 10 terabytes. I'll take 10 terabytes times my data reduction, 50%, times my bucket multiplier of 1.05, 5.25 terabytes. Now I have 250 terabytes left because the first 10 went here. This bucket also holds 10 terabytes. It holds everything from 10 to 20 terabytes. So I'll put the next 10 in there, times 50% data reduction, times my multiplier of my bucket, 3 terabytes. So now I'm down to 240 terabytes. And I can stick 80 of those terabytes here in this bucket because this holds everything from 20 to 100. So 80 times my data reduction times that bucket multiplier, 16 terabytes. Well, now I'm left with 160 terabytes, and this bucket can hold 400. So everything can fit in there, which means 160 times 50% times 0.25 multiplier, 20 terabytes. So I'll need approximately 44 terabytes of workspace for my 300 terabyte backup job, which tells me I'll need approximately 343 terabytes of disk space, right, to make sure I have space for active fulls, synthetic operations, and that means I'm going to need space too for occasional active fulls. So for a repository then, that means we're going to need 2 physical servers, that 20 CPU, 128 gig of RAM, local disk space, and each one of them will have 250 terabytes of disk space, which combined with the 2 of them is 500 terabytes, plenty for my 343 terabyte requirement. What about Enterprise Manager? How did 260 turn into 299? 299 was remember, our full week. So 260 was just the size of our full backup. 299 is the size of our, 260 is the size of our source data. 299 is the size of the backup space required for that full and all the incrementals. So when we're looking at our bucket, we're looking at the source data that we're consuming times our multiplier times the bucket. Good question, though, and good catch. You actually made me stop there. I think I had a typo. Back to Enterprise Manager. So Enterprise Manager, how do we size that? Well, this one really depends. Uh, how much are you going to use it? So we're going to start with the minimums, right? A 1 core and 4 gig of RAM. And a lot of times people are actually going to go with 2 core just because, right, 1 core for the OS, 1 core for your application. But 1 core, 4 gig of RAM is the minimum. And the space usage is going to depend on if you're doing guest file indexing or not. So we talked about X amount of meg per million files earlier. That gets compressed and set on up. Well, that's where it gets held then and is in the Enterprise Manager. So if you're doing a lot of guest file indexing, you're going to see that we need disk space there on Enterprise Manager. But really the tips for sizing Enterprise Manager are you going to use it, right? It's an API endpoint. Are you going to be using the APIs? Do you have a large environment with multiple Veeam backup and replication servers? If you do, you're going to have a little bit greater CPU usage on the box. Will you be using the self-restore portal? If so, we're probably going to want to bump up the CPU and RAM. But the recommendation is to, if you're not sure if you're going to use it, start with the minimums: 2 CPU, 4 gig of RAM, monitor it, and adjust it up if needed. If you know you're going to leverage the self-service restore portal and APIs, maybe you want to start up with, 6 gig of RAM, 6 CPU and 12 gig of RAM, and then bump it down if you find that you're not using that amount. So again, the recommendations here are deploy, monitor, adjust. Customer calculation for Enterprise Manager is basically just that. They were not sure if they were going to leverage the APIs yet, and they also were not sure if they were going to leverage the self-service restore portal. They only had the one VBR server, so for now they just deployed Enterprise Manager with 2 CPU, 4 gig of RAM. And Enterprise Manager can reside on the same server as Veeam Backup and Replication. You might want to just make sure that you give a little bit extra resources to adjust to any additional load, of course. So if you're running Enterprise Manager and Backup and Replication on the same box, then you'll want to combine those resource requirements together. So what about proxy servers? I'm sorry, combo servers, which are proxy servers and repository servers on the same box. You can see our repository role and our proxy role and our repository role. So when we're sizing a combo server, do we just take the sizing from a proxy and a sizing from a repository and add those together? No, we don't. But let's, you can see number 4 there. What we actually do is say for every task, that's going to be 1 core, 4 gig of RAM. But what do I mean when I say task? Because a proxy task is based on the number of VMDKs or virtual disks, whereas repository task is based off the number of backup chains that we're writing down. So when we're sizing a proxy server combo, what we're actually going to say is 1 core, 4 gig of RAM per every proxy task. And that pretty much covers us then on the repository requirements as well. So we don't need to do both those calculations and add them up. We can just say that 1 core, 4 gig of RAM for the proxy server per task, per proxy task. So summarizing our customer here, they had that 260 terabytes of data, 2,000 virtual machines, 8-hour backup window. We had a 10% change rate, and we had 14 days retention on premises. We also wanted those same 14 days off premises with 4 weeklies and 6 monthlies GFS. And each one of these is what we sized out, right? We sized up the backup server. We kept the recommended defaults of 4 CPU, 8 gig of RAM. Same with the Enterprise Manager, 2 and 4 for our defaults, monitoring that to see if we were going to need to consume more resources or not. We're using an existing SQL database server. So we informed them of the additional load that might be needed on there, 2 CPU, 4 gig of RAM potentially. And then we're doing the combo servers here, the proxy and repositories with 20 CPU, 128 gigabytes of RAM with local disk space and 250 terabytes. So 500 terabytes altogether, extended out with our scale-out backup repository to object storage. Well, we'll need to consume approximately 429 terabytes for our offsite and GFS copies in object storage. So Last, let's think about the laws of physics when we're talking about sizing our backups and looking at the performance of our backups. When we're looking at transferring 10 terabytes of data over a 10 gigabyte link, what can we actually do? Well, we can take 10 terabytes, multiply that down to megabytes, divide that by the pretty much throughput you're going to see, right? We're never going to see the theoretical maximum of 10 gigabytes. Field experience tells us we're actually going to be about 900 megabytes per second. So that's going to take 11,000 to almost 12,000 seconds, which calculates to be 3 hours and 15 minutes to transfer 10 terabytes over a 10 gigabit link, which means if you have to back up 10 terabytes and you have a backup window of 2 hours, it's not going to happen. So, if your backup repositories are connected by 10 gigabit link, and there's only one of them, but you need to transfer down a lot of data within a certain amount of time, maybe you need to have multiple backup repositories, each with their own 10 gigabit links. Maybe you're looking at going to 40 gigabits. Maybe you're limited to 1 gigabit per second. So you can see your theoretical and your actual field experience of throughput across that network. And so that's why I say with the laws of physics, right? We can't make that go any faster. So you need to make sure that we keep this in mind. If we're doing direct storage backups, all right, over fiber channel, let's say, that's going to be a little bit different because the theoretical maximum is going to be the actual field experience, just because of the way that Ethernet is and the way that fiber channel is. In fiber channel, you're able to actually consume all the way up to that 3,200 megabytes per second for a 32 gigabit per second fiber channel. So some takeaways here. These numbers are from the field that we used in the examples here. Be sure to visit the best practices guide and keep in mind those laws of physics or the underlying infrastructure, right? All the way from your source data stores to your proxies, if they're virtual, maybe they're physical and they're attached to your fiber channel or iSCSI network and you're doing direct storage, or maybe you're doing direct NFS. Right? So where is your backup traffic going? Is it going through the hypervisor? Is it going through the network because a hot add? Is it going over your storage network? What is it landing down on? What disks? What RAID? How many spindles do you have there so you can calculate what IO you're actually going to get? And remember that you're always going to have a bottleneck in your jobs. And the goal is to get the bottleneck where you want it to be. So if you don't want the bottleneck to be on your proxies, but you want your repository to be the slowest link in the chain, maybe you need to add additional proxies. And then that way they can send more data to where you're at the point to where your repository can't handle anymore. So now you've put your bottleneck where it needs to be. But you're always going to have a bottleneck somewhere unless you're doing some sort of NVMe over fabric for everything, which is going to get crazy expensive. I'll try to get some questions here at the end, but while we're here, don't forget, you have Veeam University, Veeam White Papers, the Help Center, Veeam Forums, and again, this will be emailed out to you afterwards as well, this deck, this presentation. And don't forget that we have Veeam Live sessions going on as well. Coming up, we're going to have Danny Allen, Dave Russell, Rick Vanover talking about some pretty cool stuff. So be sure to check out those webinars and join as well. I have a couple minutes here. Let's see if I can get some of these questions I didn't get to. Let's see here. I put a link for the calculator, was already in there, right? That rps.dewin.me. What about sizing proxies that perform replication and backup jobs? So yeah, if your proxies are going to be performing replication jobs as well, we need to keep that in mind, right? So your replication is probably going to happen at a different time than your backups. So it's not a big deal that they share those same proxies because, it's either going to be just sitting during the day when you're and then doing your replication and maybe at night doing your backups. Likewise, you can always bump those up if need be or assign dedicated proxies just to use for replication. But replication is going to be doing the same thing, right? If you're replicating a virtual machine that has 2 virtual disks, that proxy will require 2 tasks to be able to replicate those 2 virtual disks. Let's see here. Has a backup server to be placed local? I have a backup server at a remote site. Wonder if I need, okay, so backup servers don't necessarily have to be local. Best practice might say if you have two sites and one's a DR site, if you're doing replication, we always recommend that your backup server be at your off-site location, your DR location. Especially if you have a stable link, you can make that your backup server as well. And have it handle both backup and replication tasks. You can deploy your proxies and your repositories at your primary site, and your backup server can be at your DR site managing those. All your backup traffic will stay local to your primary site because the proxies are reading it, sending it to that repository, which is also at the primary site. So that way, in the event of a site failure, your backup and replication server is already at the DR site. You can spin up your replicas right away. Or if you had a backup copy repository over there, it's still connected to your VBR server since they're both on DR. You can do restores from there right away into your DR environment. So as long as you have a stable link between your two sites, you can keep your VBR server off-site, and that way it's up and running ahead of time for those operations. How can you tell what the current size of the SQL database is? SQL Server Tools, you can go in there, or you can go ahead and go look at the database files on disk. But heading into the SQL Management Studio would be probably about the easiest way. Right-click on the database, view the size of that. If you're deploying SQL Express on the VBR server, does this stack on top of the 4 cores for VBR, so we have 6 cores total? So yes, if you're going to be using SQL Express, it's going to use the first 4 cores, but we're still going to look at that default minimum of 2. If you're going to be running it on the same server with SQL Express, you can just calculate that out with that 1 or 2 cores. If you're going to be installing SQL Standard on there, you might find that you need to add a couple more to the calculation of that 4-core minimum for VBR. But typically, yeah, VBR 4 cores, SQL Express for your environment. If you have a small number of virtual machines, that 4 will still be fine. If you're going to be backing up hundreds of virtual machines, you might want to bump that up to 2 to 5 or to 6 cores. We had a question about bottlenecks and troubleshooting and what to look for. That's kind of a different conversation to get into, but again, you're always going to have a bottleneck. Look to see what it is and then start looking there for a particular issue. If it's network, start checking your switches for traffic. If it's repository, look at the CPU, RAM, look at the I/O of that repository, and then dig down from there. What does a proxy need to connect to in order to pull data in a VMware environment? So our proxies can connect a number of ways, right? Over network mode, that connects to a VMK, a VMware management port, VM kernel port. We can do hot add mode, which will take that machine's virtual disk and add it into our virtual proxy. We'll read it locally there. Or we can do network mode, direct storage mode, which will read it directly from your SAN or NAS if we're doing direct NFS. Let's see here. Does reverse incremental change the calculations to be standard incremental? So I'm assuming we're talking about space usage here. So forever forward incremental and reverse incremental will consume the same amount of space, right? That's a chain of incrementals and a full file. It's just a matter of where that full file is. Forever forward incremental, the full is at the beginning of the chain, and all the incrementals are in front of it. And then the oldest incremental gets merged into that full backup file as time progresses, whereas a reverse incremental is the opposite. You take a new backup, and you'll need a little bit more space for this because you'll take a new incremental backup that synthetically becomes your latest full backup, and then the previous full is then converted down to a reverse incremental or a VRB file. Instead of a VIB, which is your forward incremental. But space savings will be the same, although reverse incremental will have a higher I/O cost than forward incremental. Is there a way to force a backup to tape job to use synthetic over active backups? There is a synthetic tape full option there, which will create a empty file when you're doing a backup to tape job, and the server, the repository server, will go ahead and grab the bits it needs out of the full and the incrementals. So that empty VBK shell, if you will, will be used to be backed up, but it's actually just referencing pointers to all other backup points to build that instant synthetic full that we're going to be sending to tape. I have a question here in French. Unfortunately, I don't speak French, so I won't be able to answer that for you. Um, should repository servers be separate from the VBR server? We have a small environment, so we currently have our backup repositories attached to the VBR server directly, so the backups are essentially being stored locally. And that is a great way to do it. Your VBR server, your backup and replication server doesn't have to be a virtual machine. This could be an all-in-one scenario where you have a physical machine that runs Veeam Backup and Replication. It's your proxies, it's your repository, it's an all-in-one, SQL's on there, Express or standard, and everything's there. So it's connecting out to your virtual environment, grabbing the data, and writing it locally. And that's a great and very common way to deploy Veeam. Does workspace include backup logs? So the workspace that we were talking about is for the backup repository. So when we're talking about backup logs, so backup logs are going to be stored in the SQL database itself, and the backup files will be stored on the repository. So the logging space would be in SQL itself, not on the repository there. Let's see here. Can you see significant performance improvements using a separate proxy server versus running that service on the same server as VBR? That depends as well. If you have the resources, then you'll see the same performance. If you're doing that all in one deployment that we said, where VBR, proxy, and repositories all on the same machine, well, then the proxy role is just writing locally, just like in a combo server. But no, as long as you have the cores there for the proxy to consume, it doesn't necessarily matter if it's a physical or a virtual machine, if it's on there with the VBR server or not. Let's see here. Do the recommendations apply to replication? So for the proxy recommendations, they do apply to replication jobs, right? Each task is going to be a virtual disk that we are processing. Thoughts on using the NAS as primary storage for backups? NAS is on 10 gigabit on a private network of the same servers of Veeam and the VM. Yeah, NAS is a common way to do a backup repository. If you are using a NAS, I recommend that you do NFS, right? Now in version 10, we can target an NFS repository, an NFS share, and add that in as a backup repository. So I'd recommend adding in that repository as NFS and not using SMB. You're going to get faster throughput and you're going to have a more reliable repository. Be aware that when you are writing to a NAS, like what we talked about, if we need to do a synthetic operation, it's going to be your mount server. And if you haven't defined it, it's probably going to be your VBR server now, handling those synthetic operations. Does the repository have to be a server or it can be a SAN or a NAS? Yeah, so really anything. You can your repository can be a Windows, Linux server. You can be an NFS mount, SMB, deduplication device, pretty much any storage device. And there's a way that we can use it inside of Veeam. Trying to get through all these questions here. How many proxies needed for two vCenter clusters? So that really actually depends. It depends on the amount of virtual machines you're going to be processing. If you do have two VMware clusters, though, and you want to do hot add, then we're going to have VMs in those clusters to do that hot add. However, if you have proxies outside of your clusters, let's say these are, let's say we're going to do network mode. Well, then we can connect to either cluster and do network backups from the same proxy. Or if our proxies are doing direct storage mode, again, we can contact either vCenter cluster and just grab the disk's information directly across the storage network. So the amount of proxies you need are still going to be dependent on how many virtual machines you're going to be backing up. And let's see here. In a VxRail environment that has a proxy on each host what does VMware vCenter proxy do compared to the individual proxies on each host? I'm not entirely sure what you mean by the VMware vCenter proxy. A proxy for Veeam, right, is a virtual machine inside of those. VxRail is going to be running vSAN, so when we're backing up vSAN, that's going to be in hot add mode. We are aware of vSAN and where the disks are. So a lot of times we recommend that you do put a proxy on each host in a VMware and a vSAN environment, excuse me, and that way, when we're picking proxies, we can choose one of the VMware nodes that is going to be holding the majority of that particular virtual machine's data. So let's say your virtual machine is set to a failure to tolerate to 1, or I should say your policy is set to that. And your virtual machine essentially then will have 2 copies of its disks, and the majority of that copy will be on one of those nodes. So we can pick one of those virtual proxies that is on that particular node when we go to back it up, and it just helps speed things up a little bit. How to calculate resources for Veeam1 server, and can it be located on the same proxy server on the same VM? So Veeam1, we typically recommend that if you have a small environment, you can install that on your VBR server. Otherwise, you can. We recommend you put that on its separate virtual machine. On the Veeam1 ISO, there actually is a sizing spreadsheet that you can use to calculate how much space, how much resources, excuse me, your Veeam1 server will need. It's going to be based on the inventory size of your virtual environment and what type of data we're going to be processing. And we're pretty much over here. I'm trying my best to get to these questions. Because of fast clone REFS integration, we should use the Veeam dedupe and not REFS dedupe. So that's actually a good question. So deduplication and REFS fast cloning, right, in 2016 was not available, but in 2019 is available. But when you're using fast clone, right, we have those spaceless pulls, so we don't really see a whole lot of improvement from Windows deduplication on top of that. Do keep in mind, if you do implement Windows deduplication, that is a post-process deduplication. So we're still going to be consuming that amount of data ahead of time. Windows needs time and CPU to do a post-process deduplication of that data. And if it does not finish, you actually have lost more disk space because it started it and it's copied that data elsewhere for its references. But so it can cause some issues. Windows dedupe can be used in smaller environments. There are file size limits. So if your VBK is over a certain size, it used to be 1 terabyte. I think that may have gone up now in 2019 server on the file size limit. But there is a limit on what file size Windows dedupe will deduplicate. Let's see here. A couple more questions to try and go through. Is the client-side agent based using VSS? So I'm not sure if this is talking about the, let's say, the Windows agent or the small agent we inject during a backup. So if you do application-aware processing, we call that an agentless backup, right? We're connecting to the hypervisor. We do inject a small runtime into the virtual machine to do a VSS quiesce and also tell your SQL logs, your Exchange logs, and that to truncate. So then that process then is then stopped after we get that VSS quiesce, and we can back up that virtual machine in the quiesce state. And I believe that's most of the questions here that we can basically get to answering here on the webinar without getting too much time. Let's see one more here. By default, does a dedicated repository server handle the mount server or the VBR? So I believe that by default, the VBR server will probably handle it. It's actually set to automatic mode. So if the mount service is available there on that repository server, well, if it's a Windows repository, then it will be its own mount server, I should say. If it's another type of repository, then we might have a separate mount server as well. So if it's a Linux-based repository, we might have a Windows mount server to handle the front end of that. But if it is a Windows repository server, then it will be its own mount server. And but yeah, we are 15 minutes over, but I'm again, thank you everyone for hopping on. Sorry we couldn't get to all the questions, but again, please make sure to check out the Veeam live sessions. And thank you so much for attending today.